Okay, we're recording. So, there we are. Today's lesson is 1.5 volume, and then we're going to move into 1.6 after that. So here we go. First of all, what does volume mean? What's the actual definition of the term volume? And volume, and oops, I'm on a red pen. I don't want to be on a red pen. I'd like to be on a black pen. There we go. Volume is the amount of three-dimensional space an object occupies. Okay, so there's the basic definition. And they gave us lots of extra space here, so let's kind of fill that with this idea. It's measured in cubic units.
Mr. Kelly?
Question.
I can't see what you're writing.
You can't see what I'm writing? Okay, hold on a sec. Let me try one trick here. I'll unshare my screen, and then I'll share it again. Grab screen, and go back now to here, and go back to there. Is that better?
I can see, yes, it is.
Okay, so I don't know what was wrong there for a second, but sorry about that. Hopefully we're all back. Okay, now I need to go over to this screen and... Okay, still good, because now I can see the chat in the meeting again, too. Everything's still good? You can say yes in the chat if you can.
Yes.
Awesome, thank you. Okay, so let me go back to here, and there we go. Okay, sorry about that. So it's measured in cubic units, and I'll say, for example, if an object has a volume of 200 centimeters cubed, also you could call that cubic centimeters, it occupies, that's a fancy word for it takes up, the same amount of space as 200 of these. And I'll show you what I meant by these. I'm going to draw you a little cube. So let's see, I'm going to draw you a little cube. I'm going to draw you a cube. So here's how you draw a cube. You make a square, and then you go off at about a 45-degree angle and make a parallelogram. Then you make another parallelogram, and then you use dotted lines to show the lines that are there, but you couldn't see them unless the object was see-through. And this cube is 1 centimeter by 1 centimeter by 1 centimeter. So when something is 200 centimeters cubed, you just imagine 200 of these, and that's how much space it is. So that is what we mean by volume. It's how many cubic units of space an object takes up. And luckily for us, all prisms actually have the same formula for volume. Volume of any prism, oops, I forgot the I and the S, prism, is equal to the area of its base, and I'm going to actually spell the word base with a capital B, base, times how tall it is. I'll just call that height. Now I'm going to put a little asterisk
Mr. Kelly?
by base. Question?
No, I wanted to tell you that I was doing the same thing again.
I don't know what to tell you. I think the problem must be at your end. Is anybody else having an issue with the screen not staying big? There's one other thing I think I can do. Okay, I'll try this. I'll try, so nobody else is having the issue. So Can I ask you, are you using the app or are you just using the internet? Do you have the app downloaded onto whatever device you're using?
Internet.
You might want to try downloading the app for Teams if you can. That might be the issue. But
Okay.
there's nothing else I can really do. I'm sharing screen full. My screen is a little bit blurry. Okay, interesting. Doesn't look blurry from my side. I don't know what else I could do. I'm recording this, so you can, if there's stuff that you miss, I can you can watch the video later. Okay. Anyway, I'm gonna keep going here. I put a little asterisk by base. Now, here's one of the unfortunate things that happens in math every once in a while. The same word gets used for two things. When you think of the word base, you might think, oh, well, like the bottom side of a triangle is its base. But in a prism, the base is like a two-dimensional shape. It's a polygon. It's an actual square or a rectangle or a triangle or a circle. So base in this context is actually the two-dimensional shape the prism is named after. And what do I mean by named after? Well, I would call this thing, or I'll label it. Oh, here, let me move over for you. I'll label this as a rectangular prism. Why? Because the thing it's sitting on is a rectangle. And if I flipped it over, if I pushed it backwards and it landed on its back, well, you know what? It's still sitting on a rectangle. So it doesn't really matter which face I call the base on this thing. For this thing, the volume is going to be the area of the base it sits on, which is length times width. Oops, I forgot the L. Length times width. And then times how tall it is, which is height. And that's probably a formula you've seen before. For the rectangular prism, volume is length times width times height. But for objects that don't have a base that's a rectangle, like for example, actually, example 2. Take a look at example 2 here. I'd call that a triangular prism because its base is a triangle. Now, if I were to knock it over and it's sitting on a rectangle instead, so you know you don't have to draw this, but so it looks like a tent now, and it's sitting on the rectangle instead of on the triangle, that doesn't change its name. I don't suddenly look at that and go, oh, I'm not going to call that a triangular prism anymore. I'm going to call it a rectangular prism. No, it doesn't work like that. The base is the one that is not rectangular. So the base is the face that I name it after. So that's a triangular prism, and you could have a pentagonal prism, which means it'd be a pentagon attached to rectangles. You don't have to draw that if you don't want to. I didn't do a great job of it myself, but you get the idea. The lateral surfaces, if it was sitting on this pentagon, the lateral surfaces would all be rectangles. That's what makes it a prism. But the thing I name it after is the one part that doesn't actually have to be a rectangle. So I would call that a pentagonal prism. And if I knew how big the area of this was, all I got to do is times it by how tall it is if it was sitting on it. And that's volume. Volume is actually much easier than surface area. So this is a rectangular prism. So the volume here is going to be length times width times height. So let's just put the numbers in. Length looks like it's 9. Width looks like it's 13. Height looks like it's 5. And then I'm going to punch buttons. What's 9 times 5 times 13? And that's going to equal 585. Now, this is in inches cubed. So cubic inches. Every once in a while you'll see a textbook say it like this. Cubic inches. Okay? Same thing. I prefer this. Okay? And somebody might go, oh, I was thinking of it as this was length and this was width. Would it make a difference? No. You can times 3 numbers in any order you want. Where it would make a difference is on example 2. No problem. I'm recording this, so if you joined us late, you can watch the beginning of it later. So this thing here is a triangular prism. No matter which way it's sitting on a table or whatever, I think of this face here that I'll color in yellow as the base. So this volume is going to be area of its base times height. So notice I'm using a capital B so that I know I don't mean just, the base of this triangle. I don't mean a line, I mean an area. So what is the area of a triangle again? Oh yeah, you're supposed to know that one. Now I'm going to switch to little b for the base of the triangle. And, okay, you know what? I'm going to use a capital H here and a lowercase h there. Or actually, sorry, I'm going to do that the other way. I meant to do it the other way. I'm going to use a lowercase h meaning this, and I'm going to use an uppercase h meaning that. Because those heights are two different heights, right? The triangle has a height, and the prism itself, when it's sitting on the triangle, has a height. So the volume is the area of this triangle, which is 14 times 15 divided by 2, times how tall it is, which looks to me like it's 18. All right? We can make that a little bit simpler. We can just say that 14 divided by 2 is 7, so I'm going to simplify that to 7 times 15 times 18. I think I'm still going to need a calculator for it. I can't do that in my head. 7 times 15 times 18 punching buttons is 1,890. Okay, don't forget units or you lose half a mark. We are in cubic yards. And considering a yard is 3 feet, that's going to be a lot of whatever that thing's made of. Okay, any questions so far? There's prisms, right? Just the area of its base times how tall it is. In this one, the base is the triangle. In this one, it wouldn't matter which face I called the base, but I just used the one it was sitting on, the rectangle. And that moves us on to cylinders. Now, a cylinder kind of is a prism, because what's the definition of a prism again? Oh yeah, when it's sitting on its base, all of the faces that go up from that base laterally at right angles are all rectangles, right? It's sitting on a rectangle, but all the faces moving upwards are all rectangles. If it's sitting on this triangle, all the faces moving upwards, or in this case downwards, are rectangles. Sorry, are rectangles. Did I say triangles? All of the faces moving up here are rectangles. All of the faces moving down, or if you think of the base as this triangle it's sitting on, all of the faces moving laterally are all rectangles. Well, that's also true of a cylinder, right? A cylinder is a circle, and there's a big rectangle wrapped around it that's standing upright laterally. So the volume is, again, the area of its base times how tall it is, times height. But the area of the base here, well, the base in this case is a circle. So that's pi times r squared times h. And I use a capital H. Most textbooks probably won't. Again, that just reminds me that, oh yeah, I mean the height of the entire thing. In this case, there's only one h in the picture, so it really wouldn't matter if you used lowercase or uppercase. At the end of the day, I just want to make sure that you understand what the formula actually is. So that's the formula for a cylinder. Again, area of the circle it's sitting on times how tall the can is. And let's just do an example. So volume is area of the base times height, which is pi times radius squared times how tall it is, which is 12. Now, it says round to 2 decimal places. I still like, usually, to get an answer just in terms of pi. So that's 15 squared, and then times 12, which is 2,700. So this is 2,700 times pi, right? I just multiplied that part together first. And that's in centimeters cubed. And then the final volume then is take that 2,700 and times it by, and I don't know where pi is on the calculator I'm using. I almost never use this calculator. Oh, there it is. It's on the bottom. And there we go. And decimal. 8482. And it says 2 decimal places. Now, my calculator says 3.0 or 0.300, but remember, I only know that if I rounded it in the right place if I put that 0 on it. We would call that a rounding error if you didn't include that 0. Okay? All right. What's different about number 4? Number 4 is kind of messing with you. You can't assume 18 is a radius. They don't show a line that starts in the middle and goes to the end. They show a line that goes all the way across. So 18 millimeters is my diameter, which means my radius is half that, right? Because radius is the distance from the middle to the edge. So now I'm going to go to my formula. Volume is pi times radius squared times height. Pi r squared h. And once again, I think I'll figure out what 81 times 21 is. So that's 1,701 pi's, millimeters cubed of space. Multiplying that out, times by pi, is 5,343, 2 decimal places, so 0.8, and my calculator says 49, so I have to round that to a 5. Millimeters cubed. Any questions on how I did those two examples? So that's the story on prisms and cylinders. And really, a cylinder is a prism. It just happens to have a rounded face. Still a rectangular face when you think about it. So they're kind of in the same family. Area of the base it sits on times how tall it is. Next, we go to pyramids. And pyramids have a neat little rule to them. And here's how the rule works. The volume of any right pyramid, I'll talk about what that means in a second, I'll put a little asterisk by it, is equal to 1/3 of the volume occupied by a prism with the same base. And what do I mean by right prism? I mean that, or what do I mean by right pyramid? Sorry. What I mean by a right pyramid is a pyramid with a centered apex. Everybody remember from yesterday what the word, or I guess the day before yesterday, what the word apex means? Right here. This formula only works if that point makes a right angle and is in the middle of the, or actually, it doesn't even have to be in the middle, but this line here has to be how tall it is. If you move this point over and then, the pyramid didn't have triangles going around it that were the same size, then you don't have a right pyramid, and the formula then gets way, way more complicated. Here in this course, all the pyramids we're going to give you are going to be right pyramids, but I thought I'd still define it anyway. Okay, so centered apex. And so in the case of our first one, the volume here is the area of the base, is 1/3 of means times in math, times the area of the base times how tall it is. So there's how tall it is, 6.9, right? They're pointing to it in the middle there. And what's the area of the base? Well, the area of this base is that it's a rectangle. So the area of the base is just length times width. So it's really 1/3 length times width times height. And does that look familiar? Oh yeah, length times width times height is the volume of a rectangular prism. So you just imagine, you don't have to draw this, don't bother doodling. Imagine if this thing exactly filled up a box where this was the bottom of the box. It doesn't look like it when you look at it on a diagram, but the pyramid is 1/3 of this yellow box. I have some links on the blog to some videos that show demonstrations of why that has to be true. As far as we know, the person who figured this out was Archimedes. It's possible people knew it before that, but he was able to prove beyond any doubt that that has to be true. So let's plug in the numbers. What's the length? Doesn't matter which one you call length. I'll call the 4.7 one the length. The width is the 3.6. And the height has to be the 6.9. And now I couldn't do that in my head, so I'm going to punch buttons on my calculator. Can I point out to you a nice little shortcut? Timesing by 1/3 is the same as just dividing by 3. So on my calculator, here, let me bring up the calculator. Haven't played with this calculator all day. Let's see if it works. There you are. Oh, and then it jumps over there. Okay, fine. Be on the left side. I don't care. Instead of going 1/3 times, it's easier to just go 4.7 times 3.6 times 6.9, and then just go divided by 3. Boom. And there we go. So we want 2 decimal places, so that 1 becomes a 2, 38.92. And then I ask myself, I say, self, what units are we in? Cubic meters. So this must be an actual pyramid someplace. I mean, it's 6.9 meters high. That's like 2 stories of a house. Any questions on how I did that? Okay, so that's example 5 with pyramids. Let's do example 6. Example 6 has a square at the bottom. It even says it's a square pyramid. Notice, just like prisms, I name the pyramid after the thing it's sitting on. If I knocked it over and it was sitting on a triangle, I wouldn't call it a triangular pyramid. I'd still call it a square pyramid, the one face that isn't triangular. And this 7 is not how tall it is. No, 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 no. This 7 is the slant height. I don't know if you can see this very well on this picture, but the 7 here is actually on this face that's facing you. I have no idea right now how tall this thing is, because remember, its height has to go from the middle up to the apex, and I'm trying very hard to draw this nice and neatly. So if I looked at it sideways, I've got myself a triangle where that slant height is right here at 7 feet, and the height I'm looking for is actually a little shorter than that, right? And that's the line that I'm looking for. Let's go to black here. This is the height I'm looking for. What do I know about this side here? We had this yesterday. Basically, this line here that I put a question mark on is the line from there to there. What do we know about it? How long is it? I'm looking at the chat. Anybody got an idea how long that is? Somebody guessed it yesterday. It's got to be 1 foot. That's what makes this a right pyramid, right? Is that I know that this apex is centered above the base, so I know it has to be 2 feet cut in half, which is 1 foot. If this wasn't centered, I'd have a tough time doing the math. I'd need more information, in fact. Okay, so let's find out how long this is, because I'm going to need to know the height. So height squared plus 1 squared equals 7 squared, right? Because Pythagoras always says that the hypotenuse has to be the one by itself. So height squared is equal to 49 minus 1. So height squared is equal to 48. So height is equal to the square root of 48. Hey, we just learned we can simplify that without touching our calculator. What perfect square do you know is in 48? Somebody says 4, bigger. There's a 16 in it. It's 4 root 3. So the height is 4 root 3 feet. I think I'm ready for my volume formula. Volume is 1/3 times the area of the base. Well, it's a square, so it's 2 times 2. I'll just say 2 squared. Times how tall it is, 4 root 3. So my fancy answer would be 4 times 4 is 16, so 16 root 3 over 3 feet cubed. But it does say it doesn't want a fancy answer, it wants a decimal. So I punch buttons. 16 times the square root of 3. Oh, why am I doing this in here? Let's bring back the rabbit. Clear, clear, clear. Oops. Now come back. 16 times the square root of 3. Now, if you've got a calculator like mine, don't forget to close that square root so that the calculator knows, oh yeah, he's done square rooting now. And then divided by 3. Boom. And I get I want 2 decimal places, so 9.24 cubic feet. And please notice, if you don't like all the simplifying that I did here to get to that, you could have just punched this through as 1 divided by 3 times 2 squared, although I pity the person who has to actually type in 2 squared and doesn't know that's 4. And even if you didn't want to simplify this and you just said square root of 48, you're going to get the same answer. Bada boom. So there you have it. There's pyramids. Now, pyramids lean, just like prisms are basically the same thing, or let me say this again. Cylinders are essentially prisms. They just have a curved face for one of their rectangles, for their only rectangle. You can say the same thing is true of cones. Cones behave like pyramids, right? So the volume of the cone is, again, 1/3 of the area of its circle times how tall it is. That's the word circle, not circle. Circle. There we go. So putting that into a formula, 1/3 pi r squared, right, because that's the area of a circle, times how tall it is. And I'm going to use just a lowercase h. There's no other possible line that you'd call h on this thing. So let's see. Let's take a look at our first example here. We got ourselves a cone. They're messing with us. They're giving us an 8, hoping we'll make a mistake. We're too smart for that, we say. We know that that means that the radius is 4. So the volume is 1/3 times pi times 4 squared times how tall it is, 13. And again, I like to simplify before I punch buttons. Feel free to punch buttons right there if you want to. But I like to try to simplify it in my head. Let's see, 4 squared is 16. Do I know what 16 times 13 is? No, I don't. So I'm going to touch my calculator on that. Let's see. So 13 times 16 is 208. And is 208 divisible by 3? No. 8 plus 2 is 10. 3 doesn't go to 10. So that's 208 pi by 3. What are we in? Cubic millimeters. There we go. Or it wants 2 decimals, so now we punch buttons. 208 times pi, where's pi, and divided by 3. And decimal. I'm getting 217 point, how many places? 2? 82 when you round that, and that's cubic millimeters. Any questions on how I did the cone? That's how cones work. All right, just like pyramids, we can mess with you a little. We can make it one step harder. What if I don't tell you how tall the cone is? What if I can't measure it? Right? It's solid. I can't measure. I don't have any way to measure exactly how far it is from this point to the middle of the circle. But I can measure how long the slant height is. Then once again, the height plus the base is equal to the slant height all squared, because that's Pythagoras. So that's h squared is equal to 17 is 289, I think, right? Minus 49. So h squared is equal to, what would that be, 240? Somebody double check my mental math. And then if I'm square rooting 240, again, I can just leave it like that. Or I can try to think of what the biggest perfect square in it is. It has a 4. That makes 60. And then 60 has another 4. So it has a 16 in it. Is this 16 times 15? I think it is. Is 16 times 15 equal to 240? It is. So this is 4 root 15 from the last part of the unit there, from chapter 4. Again, if you just want to use 240, that's fine. Time to go to the formula. Now I know height. I'm ready to go. Formula. 1/3 pi radius squared times this height that I figured out. Not the 17. That's not how tall the cone is. Times 4 root 15. So I'll just put a little dot for times. So I'm looking at 4 root 15 over 3. What's 4 times 49? I don't even know what 4 times. 4 times 50 would be 2. I don't know, what would 4 times 50 be? 4 times 50 would be 200, so that's 196. Am I right about that? 49 times 4 is 196. Yep. So my volume is 196 times root 15 over 3 times pi. So there's the simplest answer I could give you without decimals. And what are we in? Oh, we're not in centimeters. I'm sorry. We're in inches. There we go. And changing that to decimals means punching buttons. So let's see. 196 times the square root of 15 divided by 3 and times pi. Where's pi on this thing again? Oh, there it is. Pi equals 794 point, how many decimals? Is it 2 again? Yeah. 794.93 cubic inches. Okay, I'm going to just double check that calculation. Let me just go back to the way it was in the first place here. Make sure I didn't goof it up when I simplified it. 1/3, or again, 1/3. I'll just divide by 3 instead of timesing by 1/3. Pi times 7 squared times, and instead of 4 root 15, I'll go back to what it was originally. What was it originally? It was the square root of 240 times the square root of 240. Don't forget to close that, or it thinks I still want to square root stuff. So pi times that, and then divided by 3. And that equals, there it is, same number. Cool. Finally, one last cone example here. What if we give you a problem like that? What if we tell you the volume? We know it's a cone, so we know it has this formula. Pi r squared, oh, whoops. 1/3 pi r squared times how tall it is. What if I tell you the volume's 300? And I don't know the radius. Oh, but I do know how tall it is. It's got a height of 8. What are we going to do now? The answer, we're going to do algebra. We're going to isolate r. What's happening to r? Well, r is being squared first. Then it's being times by a bunch of things. Well, let's get rid of those things that it's being times by. Let's divide both sides of the equation by 1/3 by pi and by 8. And then while we're at it, we'll get a number. So let's see. Move that out of the way. So 300 divide by, now how do I tell the calculator again that all of this is getting divided, not just the first thing I punch in? Oh yeah, use a bracket. And again, I don't care if you go pi times 8 divided by 3. That might be the easiest way to do it. I think that's what I'll do. I'll go pi times 8 divided by 3, close my bracket, and hit equals. And that's going to be then that r squared is, what's this number? 35.809 blah blah blah. Blah blah blah. And then my last step is going to be I want to square root that. Because I don't want to know what r squared is, I want to know what r is. So I'm going to square root, and no, I'm not going to repunch all those decimals. Ain't nobody got time for that. I have an answer button, so I'm just going to go answer. Boom. 5 point, how many decimal places? 2 again, so 5.98. And that's meters, right? Because radius is just a line. It's not cubic or squared. And that's the story on cones. All right, next. What about spheres? Well, the surface area of a sphere is 4 pi r squared, which is interesting. Pi r squared is a circle. If you looked at this circle that you could find in the middle of any sphere, if you were to like cut it exactly in half, the area of this circle times 4 would cover the entire circle exactly. And again, I've got some links on the blog to some videos that actually demonstrate how that's provable, which is pretty cool. But for right now, as a grade 10 student, you don't have to know how that's provable. You just have to be able to work with this as a formula. So there it is. Surface area is 4 times pi times radius squared. So the diameter, look at that, they even bolded it. The diameter of a softball is 4 inches, so that means the radius is 2 inches. Determine the surface area of the softball to 2 decimal places. So the formula is surface area is 4 times pi times radius squared. So let's plug in the numbers. 4 times pi times 2 squared. All right, 2 squared is 4. 4 times 4 is 16. So the answer is 16 pi in square inches, inches squared. but it does want decimals, so I'm going to punch buttons on that. I think I'm going to make this calculator go away. It's in my way now. So 16 times pi is 50 point, 2 decimal places, so 27 square inches. Any questions on how I did that? This is a very handy little formula. What if we want to go backwards? Suppose I tell you the surface area and we want the diameter. Well, the formula doesn't give me diameter. The formula has radius. So I'm going to solve for radius. Okay? I'm going to do something a little different this time too. You know what I'm going to do this time? Rather than put in the numbers, can you tell right away this is an algebra one again? Because I'm giving you the answer that goes on this side and you have to look for this number. I'm going to do something different this time, just for fun, just to mess things up here. Let's rearrange it to what we want before we plug numbers into it. So what we want to do is we want to isolate r. So we're going to divide both sides by 4 pi. Then it's going to look like this. Then what's the last step to get r? What did we do last time in a question like this? Oh yeah, we square rooted it. So there we go. There, that's like your own little formula for radius. Please don't go out of your way to memorize that formula. With even a little bit of algebra skill, you can very quickly find that for yourself. Okay, so here we go. Let's plug in the numbers now. Square root, the surface area is 250, divided by 4 times pi. And again, make sure you tell your calculator. Now, I think I will bring the rabbit back, because I want to show you that I can punch that in one big swoop. I can do the square root first, but then it opens a bracket for me. Then I have to make sure that the calculator knows that I'm going 250 divided by, and remember, it has to know that I'm dividing by both of these numbers, the 4 and the pi, so open another bracket. Yes, you can do that. If you've never done that before, it's super easy. Your calculators, even the cheaper scientific calculators, can open like 20 brackets inside of other brackets. I'm only doing one set of brackets inside another brackets. This is easy. 4 times pi, close the bracket for the divide, close the bracket for the square root, and hit equals. And there we go. It's 4.46. And if I stop there, I am going to lose a half mark, maybe more. What's wrong with it? I did my algebra. I put the numbers in. I punched the buttons. What have I done wrong? Anybody see what's wrong with my answer? I rounded it to 2 decimal places. What has he done wrong? Look at the question closely.
You need to look for the diameter, so
Right. Never forget what you're actually solving for. Oh yeah, we didn't want radius. We wanted diameter. So take that final answer, times it by 2, and then round it. 8.92. Which is, it was a 2 at the end, right? Yeah. Okay, so there we go. Now, we can do something fancy here. What if we had a sphere cut in half? You see, when you cut the sphere in half, this bottom that it's sitting on, whoops, that's not what I wanted to do. There we go. This circle it's sitting on now becomes surface area because it's on the outside of the object. So the surface area of that is going to be the area of this circle. And then think about it. Who could finish that formula for me? You're probably thinking, how am I supposed to know this formula? You're a math teacher, but look.
is it
If
2 pi r?
Oh, wait, you got it? What do you think?
2 pi r squared?
Right, and what was your logic that led you to that?
Because 4 pi r squared is the whole circle, so if you're looking for half, it should just be half of that, which is 2.
All the way around the outside of this thing is 4 pi r squared. If I only have half of it now, it's 2 pi r squared. So there we go. Do I have any examples of hemispheres? No, I don't even have an example. Just giving you a formula. It's going to pop up in the homework, I bet. Then, if we can do surface area of a sphere, we can do volume. And volume of a sphere is, once again, a weird little formula. One of the videos I've put on the blog on YouTube has a nice little proof of why this formula exists. It's something that it would take me a long time to kind of do on a lesson here. But it's 4/3 pi r cubed. That's the formula. So, the moon approximates a sphere with a diameter of 2,160 miles. What's the volume of the moon? And round it to the nearest mile. So volume is 4/3 times pi. Oh, once again, they're trying to mess with us. They gave us a diameter. Cut that in half. 1080, right? So 4/3 times pi times 1080 cubed. And this is going to be a huge number, which makes sense. The moon's a pretty big thing. And by the way, this isn't mile. This should be mile cube. Round to the nearest cubic mile. Imagine a cube so big that it was a mile on each edge. Do you guys have a concept of how big a mile is? You guys all grew up in kilometers. I'm like the last generation that's going to remember what it was like in Canada as a little kid, and all the road signs were in miles. I think they changed when I was about well, I guess they started changing when I was probably 4 or 5. But they changed in, like anything they roll out, they changed it in like the bigger cities and stuff and bigger towns first. And when we would take road trips and stuff, all of the stuff in the rural areas was all still in miles. Until I was probably 10 or 11, I think I could still see the odd sign that said miles. But now, of course, we're in meters and kilometers. Mile is 1.6 kilometers. So if you can imagine how far it is to walk a kilometer, imagine walking another half of that in a bit. So that's how big a mile is. And okay, let's maybe I'll get the rabbit out on this again. Let's punch buttons carefully. Come on, you. 4/3 times pi times 1080 to the power of 3. Bada boom. That's a big number. I am going to copy it very carefully. So it's 527,666. And 9286. Oh, rats, I put the spaces in the wrong place. That's why you should always write backwards. I'm going to start it over. I got the spaces in the wrong place. So let's see. 286. 669. And 527. Anybody even know how to say that number? $527,669,286 cubic miles is the entire moon. All right. Volume of a hemisphere, of course, would be just half of this. Volume is 4/3 pi r cubed, but I'm dividing it by 2. And keep in mind, 4/3 divided by 2, I can just take this 4 and this 2 and do a nice little cancel. So there's my formula. It's 2/3 of pi r cubed. So that's the formula I would use for the volume of a hemisphere. Do I have that memorized? No, I kind of memorized that one. Do you have to memorize any of them? No, we'll give you the formulas. In fact, when we test this, we'll even let it be open book. We don't care. We're giving you the formula sheet anyway. So next test will be open book. I'm thinking next week, Thursday. We'll see. We'll know more. Again, let's wait until we know what's happening next week. We don't know yet. Okay, so a hemisphere has a radius of 5. Find its surface area. So what was the surface area again? Surface area was pi r squared plus 2 pi r squared. All right? So again, let's go back. That was the formula, right? Pi r squared plus 2 pi r squared. Can I point out to you that I could probably simplify this? If it's pi r squared plus 2 pi r squared, why don't I say it's one of these plus 2 of these? And why don't I call it that? So there we go. That would have made my life easier, wouldn't it? So this is 3 times pi times 5 squared, which is 3 times pi times 25, or 75 pi. So there's my answer, 75 pi centimeters squared, but we want 2 decimal places, so I go to the calculator and I go 75 times shift where's my pi button? There, pi equals 235.62 square centimeters. All right. And then last one. What's the volume of this hemisphere? So what's my volume? Let's go back to the volume formula. Volume is 2/3 pi r cubed. So the volume is 2/3 times pi times the radius is 5 cubed. To simplify that before I punch buttons, I'm going to have 125 doubled, right? Because 5 cubed is 125. 125 times 2 is 250. So it's 250 thirds times pi. And that's cubic centimeters. 250 divided by 3 times pi equals, and that's 261 point, ooh, careful. It's actually 7, my calculator says 799. So to round it to 2 places, it's actually going to be 0.80. And that's in cubic centimeters. And that's it. There's all of today's examples for 1.5 and 1.6. I'm going to stop the video.